Computer science has done a very good job of managing computation-intensive codes, but managing data is much harder. The software that we create allows people to manage large amounts of data with a minimum of effort. Cooperative computing is the idea that people can join together all of their computing power to tackle problems that they would not be able to handle on their own. Now, the reason that cooperative computing works is because most computers are idle 90% of the day and have lots of free space that they're not using. So an example of cooperative computing that we have at Notre Dame is in the engineering department. We have hundreds of faculty, and perhaps all of them own one desktop machine and maybe a cluster of machines. And we're able to join all of their machines together into what may be called an inexpensive supercomputer of 350 machines with 25 terabytes of storage. We're focusing on data-intensive problems. The idea of cooperation has been around for many years. Lots of people have heard of systems like Condor and SETI at home and Folding at home. These systems all allow people to share large amounts of computing power. But sharing data is another problem entirely. So what we are doing is building tools that allow people to share both storage space and large amounts of data with other people, perhaps in the same university or also around the world. The first and most important problem is we always have to respect the needs of all the stakeholders. So typically people want to cooperate with people that they know. Maybe they're collaborators in the university or they're friends outside the university, but they don't want to collaborate with just anybody in the world at all. So it's very important that we put in controls that help people control who they collaborate with. The second part is fault tolerance. If you make a machine that's composed of hundreds or thousands of CPUs, you can be guaranteed that something is always broken. And anybody who's ever used a computer knows that they break all the time. So if you have thousands of machines, something is always broken. So the entire system has to accommodate this. It has to be probing for failures, and when things go wrong, it has to try an alternate plan or try an alternate resource.